Welcome to this panel discussion today. My name is Tim Deep. I'm a product manager at CA. I focus on network monitoring. How many of you attended Dan Holmes' session on NetOps yesterday? Okay, good. So what I'll talk about is one part of NetOps, which is very important, which is data collection. In the age of analytics and machine learning, the topic of the function of data collection has taken a backseat. But as you find out today from today's panel discussion, data collection has become more important than ever. An example of that is in the cloud. You all know it's very difficult to get data in the cloud. In SDN, SD-WAN networks, you know how difficult it is to get data, assemble data, and build context on the data. As networks get faster and faster, the rate of changes in networks has gone from weeks and months to days and hours, and soon it will be minutes and seconds. With that type of network, data silos like fault, performance, flow have to come together in a much more meaningful way, in the right context, being correlated, being available. That type of data is important to collect in today's network. So at CA, our Converge NetOps solution focuses a lot on data collection. We focus also on the Converge portal, but a big part of the NetOps platform is on data collection. And we strive to address these new type of networks, the fast-changing network, the cloud, the SDN networks. And we strive to consolidate these data silos, fault performance and management, fault performance, flow, packet, applications, into a meaningful context so that you have good data. But we can't do that alone. We partner with best-of-breed vendors, and some of them are here today. We partner with vendors that provide us the knowledge on infrastructures, as in SDN, ACI, SD-WAN. We also partner with diagnostic vendors like Packet Broker, active testing. And more we're partnering with orchestrators because through them we learn how to get good data, good contextual data that they can use to build future automation for you. In the last couple of years, we have recruited a number of great vendors in this space, again, from a spectrum of different areas, from infrastructure to diagnostics to even embedded technologies vendors. For this topic on data collection, we invited 3 vendors who have extensive experience and knowledge on this area. They're Netrounds, Exia, and NetLayer. So let me just introduce the panel, and they can go in to talk about data collection. Starting from the far right, we have John Defel, who's the VP of Business Development from Exia. We have Khan Babengo from NetLayer, who's the CTO of NetLayer. And then Jim Wilkie, who's the Director of North American Sales. They all have extensive experience on data collection, and they'll share with us what they learned in the last couple of years. So to start, I'm going to pass it over to John to start the discussion.
Hi, my name's John Delfell. Thank you, Tim. And I'm going to focus on packet data. And packet data, of course, has been critical for troubleshooting, monitoring, security for many years. And with these more complex and hybrid networks, that's not going away. In fact, as you can see from the quote above from Gartner, that this wire data or packet data is actually becoming increasingly important. So, because packet data provides that rich detail that's often necessary for the toughest problems. So, as wire data, packet data is becoming more critical, you run into these issues of how to get it, which is where Ixia focuses. And what I'm going to do is just want to walk through in the 3 examples of a traditional a software-defined and also a cloud environment, what are the challenges that we see as we work with our customers and CA customers as well, and then very briefly a best practice that we've seen to address the issue of collection of packet data. Okay? So first let's talk about a traditional or classic network. The key problem there is just the sheer quantity, the classic fire hydrant. And that's only getting worse as networks are increasing to 40 and then to 100 gig. And so we see this all the time. And it's not just the technical challenge and the accuracy of the data, but it also becomes a real economic issue. And how can you monitor these kind of speeds without throwing out your investment you've already made in security and monitoring tools? And so then that has a real impact. And then the other thing, what we're seeing more and more is the challenge of SSL encryption. So how do you, at these high line rates, be able to decrypt this traffic so it can then be sent to your monitoring solutions like CA APM and CA application delivery analysis so they can do their magic to make a value out of this data. Now, when you move into a software-defined network, you have those same challenges, and now more start piling up. Okay, and I'm going to highlight a couple of them here. The one is, in this case, the dog chasing the packets. He's not just having to get it in one spigot; it's all over the place. And so this is the challenge with software-defined networks, where you can't just tap in a certain spot and feel comfortable that that traffic that you need will be at that one spot. Now it's dynamic, and that's of course the beauty of SDN networks. They're constantly optimizing. The challenge is that means you need to be everywhere. So that's the next challenge. There's a lot of spots to monitor, and they move. The other challenge is that with SDN networks, a lot of the traffic goes between the VMs on a hypervisor. It never actually goes onto the network, the physical network, so you could tap or span it. So this creates a big, significant blind spot. And the other thing I mentioned on the SDN front is that the networks are more complex. So it's not just putting up a span port. Now you have all sorts of tunneling protocols that are more complex. You have to terminate tunnels, you have to strip headers, all these kind of things before you even get it to your monitoring tool. So there's this complexity issue as well. When you move to the cloud, it becomes actually a bit of a desert because there's no water, there's no packets flowing, you can't get them, okay? And so that's the challenge, it's no longer your network. And you can't call AWS and say, please put a span port on. So you have this fundamental issue of just getting the packets. And then even if you could get the packets, you have the challenge of scale and elasticity. Because the whole reason people move to the cloud is that they want to be able to have their workloads scale up and down based on the need. And of course, your monitoring has to go with that. So that's an additional challenge that you have in the cloud, in addition to just getting the packets. So I just want to share a little briefly about some best practices that we have with many customers with CA, and just kind of highlight a few of the key things. So what you see there is an ACI network, a leaf spine, and we'll talk about that first, and then we'll talk about the public cloud very quickly. But on the leaf spine, the first step is to get the packets. And so best practices is to use taps. With Cisco, it's a 40 gig BiDi tap. And then also to have virtual taps to see that traffic that goes between the VMs and otherwise be hidden. And then second, once you actually get access to the packets, you bring it together to a network packet broker. And the network packet broker aggregates it and then does the very important job of filtering. Because as these speeds increase, it's very critical that you not waste time looking at things that aren't important. So it's not just the data, it's the right data. That becomes the key. And so the filtering allows you to do that. You can do decryption. And then the last step is then to send it to the monitoring tools. And what we can do is load balance. So let's just say you're monitoring several 40 gig links in an ACI environment. You filter it, and then even then, it's still more than your 10 gig tools that you already have. What you can do is load balance it across multiple 10 gig CA ADAs, and they act like a 40, 50, 60, 70, 80 gig resource. And so you can scale. And then the other piece is automation. So We tie in also to the APIC controller so that you can then dynamically be changing different traffic depending on the network and what the needs are, all part of the context that Tim alluded to earlier. Now, when you go to the cloud, you need a little different approach. And in the cloud, what we do is we use a container-based strategy where we have little Docker containers that sit on the workloads, scale up and down, send the traffic to the monitoring solutions. So you get nice scale and total visibility.
Thank you, John. Okay, my name is Konstantin Babenko, and NetLayer is basically a company that specializes next generation networking products and solutions. At this show, we're specifically presenting our orchestrator, which is integrated with the CA suite of products with CAPC. But I want to talk a little bit about how critical it is for the orchestrator to have the right kind of data. Orchestrator is basically, if you see the pattern, would be the next logical kind of evolutionary steps from your provisioning engine, right? But it's a much more powerful concept. It's not just doing provisioning, it dynamically manages the network. And it can add resources, it can take resources, it can move resources between different entities, and it does it based on the input from systems that do data collection. And without having the right kind of data from these data collection systems, the results of orchestration could be very dangerous. The fact is that, again, based on our experience, right now with the orchestrator, you can not only provision the network, you can actually create a number of virtual networking functions, you can give them more resources, you can give them less resources. And if your data is, because of some reason, incomplete, or inaccurate, then you will have some real issues with the orchestrator because it's armed with power. That's why it's very, very critical to have the right kind of data and to collect it from every level, right? As an orchestration company, as the orchestration product, we know how complex the next generation networking environment is, exactly as John said. We have a hardware level, we have hypervisor level, we have SDN level, we have application level, we have system level, there are multiple levels. All of them can be, except for the hardware, but all of them can be dynamically changed by the orchestrator. The use case that we're presenting at this show, at the CAW, is basically an ability for an orchestrator to work in a limited resource environment like virtual CPE and take resources from one VNF, which is, for example, overloaded, and give them to another VNF that is not presently overloaded. Now, monitoring of hardware matrix like CPU utilization, memory, disk, this is granted and this is definitely important. But what's even more important is to understand what's going on inside, like what kind of packets are being flowing through, what kind of flows, what kind of network utilization is there, what's going on the SDN level. Because all of these elements, they can be basically touched and provisioned by the orchestrator. We can give more bandwidth on the SDN level. We can give more bandwidth on, we can, for example, push some routing tables around, which will allow to have, I don't know, some kind of like more direct path, for example, right? Based on this data, we can even move from one data center to another. If, for example, like in one data center, we have certain issues. So having bad data is becoming like very, very bad, very critical element. Having good data can save you a lot of basically OPEX and CAPEX money, can save you a lot of funds. That's why it's very important from the orchestration point of view to have good, clear data. And how to get it? Obviously, it needs to be collected at all levels, and it needs to be accurate, it needs to be analyzed, it needs to be correlated together. So this is what we see from our practical experience working with SDN, NFV environment, and that's basically one of the reasons why we are together with CA to get this data, because the expertise, the depth of analysis is extremely important for the efficient work of the orchestrator. Thank you,
Perfect.
Jim.
Good afternoon. My name is Jim Wilkie, and I'm with Netrounds. And Netrounds is a active test and monitoring solution. And I think John and Konstantin really brought up some good points. John brought up, a point about blind spots, and I'll talk a little bit about, how do we uncover those blind spots and really take those blind spots away. Konstantin also mentioned orchestration and really the significance of that feedback loop into the orchestration to get good data. And so those are a couple of points I think I'll key off for you guys, because I think those are really relevant to what we're doing at Netrounds. With the complexity of networks today, getting the right data at the right time, at the right point within the network is really critical. And networks are evolving. You have physical networks that are still there today. They'll probably be there for many years to come. You have hybrid networks where they're starting a migration. And then you have fully virtualized networks. And then you have cloud-based networks, as John had mentioned, some challenges there. So from Netrounds' perspective, we're really addressing all of those different aspects across the different network topologies. So from an architectural standpoint, 2 key points here is agility. And really what Netrounds brings to the table, and really our partnership with CA Technologies, is being able to monitor the network and be proactive. So when I say active test and monitoring, we're actively measuring between one or more endpoints, and we're looking at various different SLAs and KPIs within the network. But one of the things that we're doing is we're also interfacing with orchestration systems. And by interfacing with orchestration systems, not only can our solution be orchestrated, but we can also provide that closed loop back into the orchestration system, where we're providing some of that good data that they need in order to make decisions, whether it's policy decisions or decisions that need to be made for changes or deployment of our devices within the network. What's really critical is agility. We're working in a very agile network and agile ops, and being able to deploy the testing capabilities and the monitoring capabilities where you need them is critical. So here you can see on this slide, several different ways that we can deploy the test capabilities within the network. One might be a virtualized test agent that can be virtualized and sent as a virtual machine or VNF and be managed by an orchestrator, or orchestrated to run in a white box or x86 type environment. Another might be an embedded type agent that's embedded within network devices that can provide different points within the network where we can monitor and test to those different points, whether it's testing within the network or allowing your customers to test outside of your network into your network, or testing across the cloud. And we'll look at that a little bit closer in the next slide. And then of course you have your traditional, sometimes you have to deploy an appliance out there because there's no other way, legacy networks, in order to get the monitoring and the testing capabilities that you need. And so our partnership with CA Technologies has really been great because we add another dimension of data into the network ops or the performance management domain. And it's the active testing and active monitoring data that we bring to the table and feed that data into CA Performance Manager that can then be manipulated with all of the other data that CA PM is collecting today. So whether it's device data, whether it's data from synthetic traffic that we're generating across the network, whether it's data that's going into the cloud. You mentioned getting access into the cloud, or tapping the cloud in order to get a deep packet inspection or packet brokering capability was really critical. Here, being able to put an agent in the cloud and be able to go from the enterprise into the cloud is really critical too, to see the performance that you're getting to those applications, because many of the applications today are really being migrated to the cloud. And the more applications that are running in the cloud, you really want to know what the performance that you're getting. And there's always finger pointing, well, it's not my problem, it's your problem. So this is a way that we can stop the finger pointing and help isolate where problems are occurring within the network. So it shows various different scenarios there, whether we're testing in the data center. Tim mentioned SD-WAN as a real key use case that we're testing. Also just running within the service provider network, but also letting the customers test from their network into the service provider network, providing active testing, so we validate the service up front, and then continuously monitor the service once we've validated that service. And so in the next, wrong slide. So in the next slide really just kind of sums that up. So two key aspects is, first we want to validate the service. We want to make sure that the SLAs and the KPIs that you guys are held accountable for, that you're able to validate those and get the metrics and get the validation and the reports that you can share both internally and with your customers. But then once you've validated the service, be able to continuously monitor that service over its life cycle so that you know when you're not achieving those SLAs. And all of that is done what we call either a template-driven or model-driven capability for test and measurement. It's really being able to make that process repeatable by designing in kind of a DevOps type scenario where as you're deploying the service, you're thinking about how you're going to test that service, how you're going to monitor that service. So bringing that all together into kind of the final test and measurement, active test and measurement. Yep.
Thanks, Jim. So great perspective from all of you. The question that I have, in the beginning I talked about good data collection. One of the ways that you get good data is context, getting good context. So from your experience, from your domain, how do you define context? So we'll start with John.
I'll say from the standpoint of collecting the data, the packet data, the context that has kind of evolved is that we're going deeper, I should say higher, to the application layer. And so instead of just filtering at kind of layer 2, 3, and 4 where it's a broader brush, if you can go higher, you can understand the context of the traffic that's flowing and then be able to filter it more precisely to handle the scale problem. And then I would say the other piece to it is, as we alluded to earlier, about the closed loop. So if you can be filtering more tightly, at the same time getting feedback from an orchestration system or CA/ADA to say, I want more of this or less of that, it helps you work it in conjunction so you can really get just the right data dynamically.
Okay, great. Good. Khan?
I just want to again stress how important the context is for us, right? Because without the context, it will not be possible for us, not for us, but for the other system to make the right kind of analytical choices and to submit the right kind of answer for us, right? And that's why we need to know, that's why we basically need to understand it like very, very well. Based on granularity of this information, you can actually build in the orchestrator a very detailed, a very precise policy of how can you react on these particular events, how can you react on these combination of events, how can you react, for example, on some sort of a correlated event. So like context is a very, very critically important.
Yeah, definitely. Yeah, I think that's an excellent question. For us, context is really about, where can we get access to measure to a specific endpoint within the network. And we mentioned several different scenarios, whether it's within the cloud. That's one of the key areas today is how can I measure into the cloud? Because all of these applications are migrating into the cloud. I want to know if I'm having performance issues going into the cloud. So being able to have an agent that's in the cloud that can measure from the enterprise into the cloud, that's very contextual and getting the context from the cloud perspective and that endpoint. Am I having problems there, or am I having problems in the network, or somewhere in between? And so, isolating the complete service chain. I think we've worked with CA and we've looked at different service chains. And actually, maybe some of you folks came by the booth and we talked about, well, if I have a firewall issue, how can I segment that and really get the context of where is that problem occurring within the network? And that's really the ideal scenario for a solution like Netrounds, is being able to segment and isolate the context down to where the problem's occurring, whether it's in the cloud, whether it's a specific component within that service chain.
Okay, thank you.
And what's
Great.
kind of interesting is that each of the different data sources have different perspectives on the context. So it's interesting that you can kind of leverage, for example, synthetic tests, because it gets a certain a viewpoint that's critical, and then you might say, okay, well now maybe I want to see the packets, or maybe I don't because I don't need it.
Exactly.
And so the different data collection and a good analytics engine, orchestration engine, kind of work in harmony to gather the right information at the right time from different sources.
Okay, great, great.
Yes.
Thank you very much.
Thank you.